All right, guys, welcome to part two of the discussion. Um, I intended to clean this board and start drawing stuff or descriptor sets from a different perspective, but there are some slight modifications that I wanted to make to this picture in order to make sure it was absolutely clear and that you guys understand what is going on. The major modification is basically that this descriptor set layout box really should encompass these two guys here. Okay, so the descriptor set layout is basically covering all bindings, and right now I have it just covering just covering binding one. And I was thinking of modifying it off camera, but I figure that in order for you guys to get a full understanding, it would be smarter to just do it on camera. So I meant to say that this descriptor layout binding section really and truly should be a part of this guy right here. All right, and let me just get this. But even as I'm making the changes, you guys could really, contemplate and think about what I'm saying in the meantime, right? So, my hand is lean today. I don't know what's going on. I'm just not used to drawing like this. But anyway, just bear with me. All right. So, all right. Okay. So, binding one, binding two, and this conversation here is encapsulated. Hold on. Let me get a different color. How about that? This descriptor layout conversation is encapsulated, or the binding conversations, binding one and binding two, is encapsulated within the descriptor set layout binding. So let us review again. We have our descriptor pool, which is hardware resources to even have this stage that we have here. We have descriptor set allocation, which is defining how many descriptor sets and all of that. And remember, the number of descriptor set is usually very low, and it's dependent on the kind of hardware that you're running on, GPU hardware that you're running on. It also depends on whether it's like a desktop, laptop, or like a mobile device. Some things have different limitations in terms of the number of descriptor sets you could have. Okay, so we define our first descriptor set, and then within the descriptor set we have a layout, right, which is very, very important. This is probably the most important piece of the descriptor set discussion, the descriptor set layout, because it's this structure is used in more than one place, and you will see that in the next mental model that I'm going to draw. So we have our descriptor set layout, and within the descriptor set layout we have descriptor set binding, which is this blue area right here, and within the binding we basically define all our bindings for what we want. Again, descriptor sets are about having Vulkan access memory objects, memory resources. That's usually the memory is usually associated with the CPU and managed by the CPU. So descriptor sets help Vulkan to get memory objects off of, you know, memory and on the CPU, your SSD drive or whatever, and get it into the GPU. In the next mental model, we will discuss that further. But so you tell Vulkan, okay, this is a UBO that I'll be accessing, and I define the pipeline stages that I will have access to this. I'm defining an image buffer, an image I'm trying to access, and I define the pipeline stages that can access this image buffer. Of course, all the other pipeline stages are not allowed to access this resource, only the ones that you specify within the descriptor set layout, binding, and descriptor set conversation. Of course, if I make any kind of oversight or whatever, I will make another video to you know, discuss it further. But I think this right here is a very good mental model of how descriptor sets work. Again, the idea is to get memory objects, memory resources off of your storage device and into the GPU memory so that Vulkan can display it on the screen. And not only to get it on the GPU memory and display it on the screen, but do it very fast. So, you know, for like UBO stuff, the camera system, all of that stuff, you wouldn't go through a vertex buffer because it's apparently it's not fast enough or something. It's just not as efficient and quick. And remember, you could update these things per frame, per draw call, per render, per whatever you want to call it. But literally, so you know, when you're doing computer graphics, 30 frames per second, 60 frames per second. So all of this stuff has to be happening very fast. If the UBO changes, it has to be swiftly put into GPU, video RAM, and then displayed on the screen via the Vulkan API. All right. So I think I'm comfortable with what I've outlined here. And let's erase this and draw a new model. Now, the new model that I'm gonna draw, it's more granular, but it will help you to better understand what this is. It's kind of good that this is part of the part 2 video because you could always rewind to see this image quickly. I'm going to put you through the torture of watching me erase this model, but I think it's good for you because it will give you time to reflect and recalibrate so that when I start drawing the new stuff, you will be ready to absorb all of that new information. All right, here goes nothing. All right, let's not forget that we are CUDA Education. And you guys should be visiting the website CUDAeducation.com. You will have access to a bunch more videos, tutorials, all of that good stuff. All right, so this is part 2 that we are embarking on. Let me okay, so for this conversation, we are now going to outline the relationship between the CPU and the GPU. I have done the CPU, GPU section stuff in previous tutorials, and we are going to do it again. And the reason we're going to do it again is because it is very important. Okay? So, let me see. All right, so I'll just do CPU over here. And then I'll have our line of demarcation, if you will. And then we're going to have our GPU. Okay? Now, so we have our CPU and we have our GPU. Okay? Now, as you guys should know by now, the CPU is where most of us live. When we use our computer, when we're using Visual Studio, when we're typing code, we're basically doing it on the CPU side of the equation. So C++ code. Okay. And then also, you know, when we're declaring, you know, for example, uniform buffer objects. So, you know, we're declaring the data and what it's supposed to do and all that stuff, the model view projection data, model view projection data, okay? All of that stuff is sort of declared CPU side, okay? Now, let us get into actually doing some Vulkan related code. Now, we're doing this Vulkan related code, but understand that this is all still CPU side. So, one of the most low level, one of the most closest thing to our data that we did in the previous picture was the descriptor set layout binding. Okay, so let us actually so I'll just section this off. This is just, you know, separate stuff. Okay, right? So we have our descriptor set layout binding. Okay, so you guys remember about the binding, right? We just finished looking at a picture about it. All right, so we have our binding here that we define. Okay, and again in tutorial number 14 we go through the actual code of this stuff. Okay, so we have our descriptor set layout binding where we basically describe the number of bindings that we have. So in our main example in the previous picture, we had, you know, binding 1 and binding 2. Okay, and we, you know, and you know, binding 1 was UBO memory type, and it was accessible by the what is it, the vertex shader. Okay, that's fine. All right, so we're talking about camera system and all that stuff or what have you. All right, so we have our descriptor set binding. Then we have a little bit higher level, simply the descriptor set layout, right? And this was just, you know, the higher level construct that we had in our previous picture, right? No surprises there. We had our descriptor set layout, and then we got to the binding, but we're doing it in the reverse now. So we have the closest thing to our data descriptor set layout binding. Then we have our descriptor set layout, which is, you know, the just the layout. Now we have a little extra stage here that I'm going to outline here that I didn't really discuss in the previous picture, but it is still very important. So remember, this descriptor set stuff, basically, it has to always be bound to the pipeline, the graphics pipeline, or you know, just the pipeline that we're using to set stuff up to render to the screen. So all of this descriptor set conversation ultimately results in binding to a pipeline and getting it you know, binding to a pipeline and then rendering to the screen, right? So when you're binding to the pipeline, you always have to make sure that your descriptor set layout binding is properly situated, and your descriptor set layout itself is properly situated. Basically, you're just doing the homework, the initial setup, so that when you bind to the pipeline, you know, the pipeline knows what the descriptor set is about, what kind of memory it has, you know, all of the declarations, memory type, what pipeline stages can access it, all of that stuff. So this is a little extra step that we didn't include in the previous picture, but it is very important because we are discussing what it is that we want to. We're discussing what it is that we want to set up for you know, for rendering to the screen. All right, I'm not going to labor the point anymore, but now after the pipeline layout, there's some other considerations that we have to make. All right, so let me just pause here and let's go over to GPU side. All right, so on the GPU side, we have this big wide area that's considered the GPU. So if NVIDIA GPU is your favorite GPU, kudos to you. If it's AMD, kudos to you. I can't think of any other GPU types on the market right now, but that's okay. All right. Within the GPU area, we're going to make a distinction between different pieces of the GPU. Okay? So let us, I'm going to do a dashed line here that basically just represents, you know, partitioning, if you will. Okay? So on this side of the GPU is everything that Vulkan can see, right? So anything on this side of the GPU, or that eventually points to this side of the GPU, Vulkan can see. And I will make an important consideration at the very end, but I'm not gonna say it right now. So this we're gonna call Vulkan, and I don't even know how to write like this, but Vulkan API. All right, I apologize for the whatever, my hieroglyphics, but it's all right. Okay, so Vulkan API on this side of the equation. And on this side of the equation, it's just simply what I like to call GPU VRAM. Okay? GPU VRAM. So on this side of the equation, we have GPU VRAM. On this side, we have the Vulkan API. And I don't really like how this looks, so let me just do it over again. And I'm not even going to bother doing it. I'll just call this Vulkan API. All right. And then here we have our GPU VRAM. Okay. All right. GPU VRAM Vulkan API. Vulkan API only sees stuff that's pointing to or is on this side. GPU, video, it's basically video memory. Okay? We're just gonna pause there. So after the pipeline layout, we now get to our descriptor. All right, you guys remember the descriptor pool from the previous video and the first image that we had in this video, right? So we have our descriptor pool, okay? And then the next thing that happens after the descriptor pool is going to be descriptor set allocation. And again, in the previous video and in the first image, we discussed descriptor set allocation. Okay? All right. So video RAM in the GPU, descriptor pool, descriptor set allocation. Okay? All right. So we go descriptor pool, then we do descriptor set allocation, and then now there is a specific reason why I put these things over here, but I'll discuss later, right? And then we go back over here. So we go back over here to, and I'm sure you have, right. So we go back over here to VK write descriptor set and VK update descriptor sets. All right. So this is just still purely CPU side, okay? So let us review. We have our CPU, we have our GPU. Way on the right hand side, we have our Vulkan API, which nothing is happening at the moment. On this side, we have our GPU VRAM, right? When we start out, we have our descriptor set layout binding, which is the closest thing to the data on our SSD or you know, memory, hardware device, whatever, right? Then we have our descriptor set layout. So the descriptor set layout binding is you know, declaring each of the memory objects that we're trying to access. Descriptor set layout binding is just a higher level container for all of this stuff, right? And it basically defines, you know, the bindings and everything, right? Then we have our pipeline layout, which is basically just dancing with the graphics pipeline and telling the graphics pipeline, hey, you know, this is what I'm about. I'm a descriptor set here, and this is what I want to do, and blah 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 blah. Okay. Then, after the pipeline layout, we go and we create a descriptor pool, and of course, the descriptor pool is tasked with managing hardware resources for our descriptors. And of course, if we're managing hardware resources for our descriptor, and remember Vulkan by definition descriptors by definition is concerned with having Vulkan access stuff on the you know, our storage device. The descriptor pool, when we say it's managing hardware resources, we're really talking about the GPU video memory, right? That's basically what we are concerned with. 1 second. Right? So that's what we're concerned with. So this whole conversation here is concerned with GPU, video RAM, GPU video memory, GPU video resources, all of that stuff, right? So we start allocating hardware resources for our GPU. Then we do our descriptor set allocation, which is just a little bit more granular, because now we're trying to define how many descriptor sets we have, blah blah blah, right? And then once we're done managing resources and telling the GPU or the device how many descriptor sets we're gonna have, we eventually get to VK write descriptor set and VK update descriptor sets. Now the VK update descriptor sets is an actual function. The VK write descriptor set is like a vector array of stuff, and I guess that would hold all of your descriptors and everything. But the VK update descriptor set is the real big man in town, right? This guy right here. That's what actually writes the descriptor set, and then that's what makes it visible to the Vulkan API. Okay? So the Vulkan API, only after this VK update descriptor sets is run do you have Vulkan being aware that, hey, we have some objects in memory that we want to have access to. These are what they are. This is the layout binding. This is the pipeline stages that can access it, all of that stuff, right? So look at how much work we have to do beforehand before Vulkan even knows that this stuff exists, right? And very important, look at the GPU video memory conversation here. I know that in the latest NVIDIA GPUs and stuff, and even the AMDs, you know, a hot topic is how much video RAM does the GPU have. So I don't remember, 8 and 12 gigs or something. I don't remember. But there's been, like J2Sense and all these guys, there's been discussion about video memory on the GPU. How much does it have, and how does it affect performance for your video game or for your graphics workflow and performance and all that stuff. I believe that conversation is, you know, it has something to do with this, right? So obviously the more descriptor sets you're able to have and to use, because you have more video RAM and video memory, and it's, you know, it maybe the quality of the video memory is better than other brands of GPUs. I don't know, but I believe that maybe this has something to do with it. So again, a lot of typing on the source code on the CPU side. I mean, this is still source code, and this you actually still type this out on the CPU side. Don't get me wrong. It's just that when we're actually declaring this stuff, we're dealing with video RAM to a certain degree, right? And then the final piece of the puzzle is this VK descriptor set conversation. So maybe I'll put a star beside this guy right here, because this is the star of the show, this VK update descriptor sets. And once this fires off, assuming all your other declarations are correct, then the Vulkan API is aware of the memory resources that you're declaring and can access it and can do what it does. All right? And that's pretty much it for descriptor sets. So between the two pictures, it really should help you to have a good understanding of how this game works. Now, I don't want to confuse the situation much more, but I will say, let me see if I can find another color. All right, you guys like orange or purple? Which one do you like? Which one you feel like? Which one you feel like? Which one you think? Which color you think I should? Which color you think I should play with? I am going to go with. I'm going to go with purple just because we already have the red, and like the things I'm trying to do is close to this guy, so I'll run with the purple. Okay, so this descriptor set layout thing, there are two things that really use it, okay, and it's very important. This guy right here, obviously, because it's connected, and then also this guy right here. All right. So in the previous video and in the start of this video, I really emphasize the descriptor set layout, and it's because it's used in a pipeline and the descriptor set allocation, right? So that's why, and that's why it's, you know, why we want to make sure our layout is done properly and everything, because it's really the thing that a lot of other things use. I'm gonna erase it out though, because it just doesn't make my picture look nice and clean, and I like nice and clean. All right, so that's pretty much it, guys. I mean, when you see the picture, it's not too bad, right? When you see the picture, it's not too bad. It's actually, you know, pretty straightforward. But again, you know, what trips up a lot of people is that there are a lot of moving parts, and it's hard to really see this stuff when you're banging down on code and stuff. But if you just take a step back and map things out, you will kind of have a better idea of what's really happening and be able to get what you want done. All right. So guys, remember tutorial number 14. Tutorial number 14. Let me maybe I'll do it in purple this time. Yeah, green and purple. Anyway, tutorial number 14, guys. I'm gonna have the link in the description below. That uses running code that you should have on your Windows-based machine, assuming you have a Vulkan capable GPI. It features running code, and I actually go through these concepts in actual code. The code again is courtesy of Sasha Willems, and he thankfully offered it freely available on GitHub for the world to use and to consume. But so we go through that code and we kind of discuss these same concepts again. Again, if you want to have the example code install and run on your machine, you're gonna have to look at tutorial number 13. Tutorial number 13 goes through getting the example code that Sasha has running on your Windows-based machine. But so you do 13, you get it running, and then you go through 14 where we're actually going through lines of code and discussing this stuff. I will reiterate, not necessarily, but I will reiterate that you know, Vulkan is not aware of anything that's happening over here until this fires off. Okay? It's completely oblivious to all that's going on until this fires off. And in order for this to fire off, you have to do a whole lot of work to make sure it doesn't throw an error or anything like that. The uniform buffer objects, in the code that I have in tutorial 14, it's a planet in the middle, and it's rocks circulating the planet. So it's like you're in outer space, you have a planet in the middle, and you have rocks circling the planet. The rocks itself are also rotating. There is a camera system, and the UBO manages the camera system. So when the image is rendered on your screen, and you use your mouse to scroll in and out, to zoom in and out on the scene, it's being initiated as a user. You're a user on the CPU side. You're updating the uniform buffer object, which is the camera system, the model view projection data. You're modifying this data. And when you're zooming in and out, or rotating the whole scene, the uniform buffer objects, like the matrix that deals with the matrix for the camera system, is being changed. When it is being changed, it eventually goes to the changes go to VRAM, and it eventually goes to Vulkan API, and then you actually see the changes on your screen. So if you're zooming in, you see the scene zoom in. If you're zooming out, you see the scene zoom out. If you click on the scene and try and move the whole thing, you'll see the whole thing kind of move, based on the fact that the camera system data is changing. But you have to kind of go through this whole process in order for Vulkan to render the change. Okay? And of course, it's supposed to happen really fast because we're using descriptor sets, and these changes can happen on a per frame basis, right? So you're not going to use any other methodology to manage your camera system, or any kind of, transformations that you're doing, because it's slower than doing descriptor sets. All right? And that's pretty much it. Definitely support the channel, kudaeducation.com. Definitely subscribe to the YouTube channel. I'll be making more videos on Vulkan. For the time being, I'm going to focus on Vulkan API graphics capabilities, but in the future, I plan on also talking about the compute stuff. Vulkan is a GPU, it's basically designed around the GPU, if you will, and you could do a lot of parallel processing directly with Vulkan. You don't necessarily have to be rendering something on a screen or doing graphics with Vulkan. You could do parallel processing, high performance computing. I did some of this stuff with NVIDIA CUDA, but of course it's CUDA is about speed and parallel processing and high performance computing, but it's only proprietary to NVIDIA GPUs, whereas the Vulkan API, it can use any modern GPU that works with Vulkan. So you could get parallel processing and speed up your application through Vulkan capabilities. That's all I have for today, guys. The next thing that I probably will be working on is the Vulkan instancing, but I still want to tackle some other stuff. I'll probably be doing instancing next, though. All right, definitely support the channel, kudaeducation.com. Subscribe to the channel. Definitely buy the tutorials. As I said, tutorial 13 is installing the example code. Tutorial 14 goes through the code for this conversation. Tutorial 1 through 12 is a different code set, and it's just going through the very basics of Vulkan. So validation layers, vertex buffers, just everything else pretty much. So if you really want to learn Vulkan, definitely get those tutorials too. $2.99 a tutorial, guys. You can't beat that. Less than the cost of a coffee. So if life is really hard, you could always skip on that Starbucks coffee one morning and get a tutorial. It's not, and it's a video tutorial at that. So video walkthrough. All right, guys, I'm done here. Have a great day. Goodbye.